Welcome to our lesson today. I'm your presenter MJ, and I would like us to look at the qualitative analysis of organic and inorganic chemistry, which is very important when it comes to the chemistry practical bit in high school, and very important for chemistry paper 3 exam. And before we begin, I would like us to look at some of the acronyms that help the learners to understand the concepts very fast and internalize them. So the first acronym is KUFEFE, that is for the colored ions. We are having ZAP, that is for the ions, the lead ions, zinc ions, and aluminium ions, which usually form a white precipitate with the sodium hydroxide that is soluble in excess due to the amphoteric nature, because you remember that these three ions usually form complexes. We have Merkaba, that is for the ions which usually form white precipitate with the sodium hydroxide that is insoluble in excess. We have Caleb for the insoluble sulfates. We have Sosokokle for the insoluble lead salt. This one is going to be very important when it comes to the areas whereby the learner will be adding lead nitrate. If he or she sees a white precipitate, then it means either the sulfate ions, the sulfide ions, the carbonate ions, or the chloride ions are present. And then lastly, we are having layer, that is for the insoluble chlorides. Now, when you are in the laboratory, we are expected to make observations, and when an examiner tests you in this chemistry paper 3, when he or she requires you to make the observations, what is he or she testing? The observations usually entails what you are going to smell, what you are going to see, and lastly, what you are going to hear, because you remember, as you are carrying out the practical, maybe if you are having bubbles being produced, there is some sound you are going to hear, or if you are hitting a salt, you can hear a cracking sound, the cracking sound that you usually call the decapitating sound. So like for instance, when you hit lead nitrate, you usually hear some cracking sound, just because the water of crystallization inside the crystal is expanding, therefore making the crystal to crack. So let us begin with the test for cations. Cations are the ions with a positive charge. Now we will look at this in form of an example, like a question. Like for instance, you may be given a solid, it has been labeled as solid D, maybe solid Z, or whichever the letter. And one of the questions that you can be asked in that particular given area is number one, for you to be able to describe the appearance of that particular given solid. When an examiner asks the learner this one, the examiner is expecting the learner to look at the solid and tell if that particular given solid is a crystal or if that particular given solid is a powder. And then number two, the learner is also expected to take note of the color of that particular given solid. So, like for instance, if I ask you to describe the appearance of a given solid, I expect you to make statements like, I have seen a green crystalline solid, or I have seen a white crystalline solid, or I have seen a white powder, or I have seen a colorless crystalline solid, etc. So you need to take note of the color and also tell the examiner if it is a crystal or if it is a powder. Now, I was able to download a few images from the internet that can help us to understand whether a given solid is a crystal or a powder. Now, like for instance, you have that first solid. When you look at it, you need to determine, is it a powder or is it a crystal? You also have that second one. You also have that third one. We need to try and see, are they crystals or is it a powder, and what is their color? Like for instance, the first one, I'm expecting the learner to tell me that she or he has seen a green crystalline solid. The second one, a blue crystalline solid, and this third one is a powder and it is white in color. If you try and look at it, when you are feeling, if you want to determine whether a substance is a powder or a crystal, you need to feel the texture. That sorry, that texture tells you whether it is a powder or a crystal. Now, for the second bit, the second part of the question, you may be asked to take that particular given scoop, half of the solid that you are having, and put it in a boiling tube, and then you heat gently and strongly and test for the gases that have been produced, either using litmus papers or using a burning splint or using a glowing splint. Now you should be able to take note that when you are asked to heat gently first, the examiner just needs you to try and determine, does that particular given solid contain water of crystallization? Then when you are heating strongly, now in this particular given case, you are trying to look at it, is it going to decompose? And as it decomposes, what effect are the gases that have been produced going to have on the litmus papers, on the burning splints, or on the glowing splints, and so forth? So the first observation, if you are carrying such kind of an experiment, one of the observations that you expect is that you may see a colorless vapor condensing at the cooler parts of the boiling tube, of which in that particular given observation is trying to tell us that the solid that we are having contains water of crystallization. So the inference the learner can talk about, that particular given solid contains water of crystallization, or the learner can say that that particular given substance is hydrated. And then as you are carrying out that same experiment, remember you are asked to heat gently and then you heat strongly. So when we did heat gently, we saw a colorless vapor forming at the cooler parts, which told us the substance is hydrated. Now, which observation are you going to make when you heat strongly? When you heat strongly, like for instance, I can see that the substance may be decomposed and it produced a gas that changed the moist red litmus paper to blue, and the blue litmus paper remained blue. If the examiner tells you to test the gases using blue litmus paper and also use a red litmus paper, you must give an observation of what you saw when you used the blue litmus paper and also when you used the red litmus paper. So in this particular given context, like for instance, you are seeing an example, you can see a colorless gas that changed a moist red litmus paper to blue, and moist blue litmus paper remains blue. The inference for that particular given case, you are going to have ammonium ions being present. And take note that I have indicated that I am using a moist red litmus paper. The importance of us talking about a moist litmus paper is because a moist litmus paper usually provides a medium for the dissolution of that particular given gas that has been produced. Because remember, when the litmus paper is drying, that particular given gas lacks a medium for the dissolution of that gas. So even in the exam, if the examiner has not told you to use a moist litmus paper, always remember to moisten that particular given litmus paper before you test for that particular given gas that has been produced. Or alternatively, you can be asked to test for the gas that has been produced using a burning splint. Now when you are using a burning splint, we are trying to see what is going to happen to this burning splint. So like in my case, I'm trying to look at an example whereby the colorless gas that has been produced has put off a burning splint. And when it puts off this particular given burning splint, for our case, we are going to look at the carbonate ions or the hydrogen carbonate ions being present. Because we remember when you are decomposing a carbonate or a hydrogen carbonate, usually we produce carbon dioxide gas. It is the one that is actually making this burning splint to go off. Next, you can also now be told that, remember you had a solid, you have scooped half of it and you are remaining the half. So the remaining half, you are usually told to place it in a boiling tube and add water to it, add distilled water to it. Now, as you are adding the distilled water, remember every moment you are carrying out an experiment, you should be able to take note that maybe you should be able to have an expectation. What may be the outcome of whatever I am doing? So, like for instance, when you are adding water, you are expecting either that particular given solid is going to dissolve or it will fail to dissolve. Of course, you are going to get some questions that are telling you add water and filter. So in such kind of cases, what are some of the observations that we are expecting? You can have the solid dissolving to form a colorless solution. In this particular given case, it is good you need to tell us when you added water, what did the solid do? It dissolved. Then it formed a solution. It is also good to take note of the color of that particular given solution, because it is going to be very important for us when you are making the inference. So in this particular given context, since the solid dissolved, it is leading me to the inference that that particular given substance is soluble. And since it formed a colorless solution, it implies that now the colored ions that we have are not there. Because remember, we are having so many ions which are colorless. So it's good for us now to go in for the negative inference, where we are now going to talk about the iron 2 ions, iron 3 ions, and the copper ions being present. So those colored ions are not present. Alternatively, you can have the solid dissolving to form a blue solution. When the solid dissolves to form a blue solution, so the first bit, the solid is dissolving, we have to first of all make the inference by talking about that particular given substance is soluble. Now, when you get to the second part, the color of the solution, if it's blue, now it will be telling us that the copper ions are present. Alternatively, you can add water and see the solid dissolving to form a green solution. Now, if it is forming a green solution, it implies that I understand that mostly we are used to the iron 2 ions being forming green solution, but we should also be able to understand that some salts of copper usually, when you add water to them, they also form a green solution, and that is the reason as to why I have included copper here. So it can either be copper ions being present and or iron 2 ions being present. I understand most people are only having the misconception that it's only iron 2 ions which are green in color when in solution form. So get to also understand that we have salts of copper which are green in solution. And then if the solid dissolves to form a yellow solution, now in this particular given case, it will mean that the iron 3 ions are present. Now, in some cases, you are going to find out that as you add water to that particular given substance, you may still see some solid particles being left at the bottom of the boiling tube that you are using, and in some cases maybe the examiner may ask you are adding water and filtering. So when you add water and filter, it signifies that maybe at some point, maybe the solid that you are given was a mixture of two salts, of which one salt was soluble and another salt was insoluble. So in this particular given case, if you add water and then you shake well and still find that some solid still remains in that particular given boiling tube, you are going to come and make your observation and say that the solid partially dissolves to form, then also now look at the color of the solution that you have remained with. Yes, I am having a solution, its color is colorless, and then I am having some solid remaining in it. So you make your observation by saying that the solid partially dissolves to form a colorless solution. Partially dissolves implies that some part dissolves and another part does not dissolve. Now, since you have said here that that particular given solid partially dissolves, it implies that that particular given solid that you have been given is composed of a soluble and an insoluble salt. And since the solution is colorless, it implies that the colored ions are absent. That's why I have talked about iron 3 ions, iron 2 ions, and copper ions being absent. Remember, if I'm to talk about the ions that are being present, there are so many of them. So I may not be able to exhaust, but so the best way to make your inference here is go for the negative inference, where you talk about the colored ions being absent. So you talk about iron 3 ions, iron 2 ions, and copper ions being absent. Alternatively, you can have that particular given solid dissolving partially to form a blue solution. So if the solution is blue, talk about copper 2 ions being present. If the solid partially dissolves to form a green solution, talk about copper ions and iron 2 ions being present. If it partially dissolves to form a yellow solution, talk about iron 3 ions being present. So you should first of all remember, you should infer. The first inference comes from what happens when you added water. Did it dissolve or did it not dissolve? So if it doesn't dissolve, it implies that it's a mixture of soluble and an insoluble substance. And then the color of the solution can help us to identify the possible ion which is present. Next, we have the use of sodium hydroxide. Usually talk about dropwise until in excess. So you can have it forming a white precipitate which is insoluble in excess. So it means magnesium ions, calcium ions, and barium ions are present. That is where the acronym MACABA comes in. If you have white precipitate that is soluble in excess, it means the zinc ions, aluminium ions, and the lead ions are present. Now that is where ZAP comes in. And if you have a green precipitate soluble in excess sodium hydroxide, so this is supposed to be a green precipitate, not green precipitated. Green precipitate insoluble in excess sodium hydroxide, you have iron 2 ions being present. And then if you have brown precipitate insoluble in excess sodium hydroxide, iron 3 ions are present. Then we can also expect a blue precipitate insoluble in excess sodium hydroxide. That is, it implies that copper ions are present. Then we have a case whereby you are adding in the sodium hydroxide from the first drop up to the last drop. You were expecting a precipitate to be formed, but now there is no precipitate forming from the beginning till the end. So in this particular given case, you should now be talking about the ions that you are expecting to form the precipitate being absent. We were expecting magnesium ions, calcium ions, barium ions, zinc ions, aluminium ions, and lead ions. We were expecting them to form a precipitate. So now, since we have not formed a precipitate, we now say that those particular given ions are absent. Because remember, I told you that when you are making an observation, you should first of all have an expectation. Next, we have ammonia solution, addition of ammonia solution until in excess. You can have it, if you have it forming white precipitate insoluble in excess, it will imply aluminium and lead are present. Remember, this ammonia usually helps us in the first step. Remember, I was using sodium hydroxide. So this ammonia solution usually helps us to identify between the zinc, aluminium, and lead which one may be present. If you see a white precipitate insoluble in excess, it means aluminium and lead are present. So which implies that zinc is absent. But when you see a white precipitate forming which is soluble in excess ammonia, it implies that zinc ions are present. And if you see a green precipitate insoluble in excess ammonia, it implies that iron 2 ions are present. And if you see a brown precipitate soluble in excess, sorry, this is supposed to be a brown precipitate insoluble. It is not soluble, but instead it is supposed to be insoluble. So this is a single word. Brown precipitate insoluble in excess ammonia. You are having excess. You are having iron 3 ions being present. If you are having a pale blue precipitate which is soluble in excess ammonia to form a deep blue solution, it implies that copper ions are present. And if there is no white precipitate, so I'm adding in ammonia solution, and from the first drop up to the last drop, there is no white precipitate that is being formed. It will imply that calcium ions and barium ions are. Now, the next reagent that you can that we use in the laboratory is potassium iodide, and this one is simple. potassium iodide usually helps us to identify if lead ions are there or not. So if you see a yellow precipitate, it means lead ions are present. If you don't see that yellow precipitate, it implies that the Now, the next reagent that we can be asked to use is sodium sulfate or any soluble sulfate. So if you see a white precipitate, it means calcium, lead, and barium ions are present, because remember, in this particular given case, it is only calcium, lead, and barium sulfates which are insoluble, so they are the only ones which are going to form the white precipitate when you add in any soluble sulfate, and that is where the acronym CALEB comes in. But if you do not see a white precipitate, remember, as you are adding in that particular given soluble sulfate, you are expecting a precipitate. But if you now don't see it, it will mean that the calcium ions, the lead ions, and the barium ions, which you are expecting to be there, are now absent. The next reagent that we can use is a chloride, sodium chloride, and then we warm. So here we can use any soluble chloride. If you see a white precipitate, remember we are only having two chlorides which are insoluble. That is lead chloride and silver chloride. Lead chloride is soluble on warming. So if you see a white precipitate that is soluble on warming, it means that lead ions are present, which implies that silver ions are absent. But now, when you form a white precipitate that is insoluble when you warm, you are going to talk about silver ions being. Now, the next test is the flame test, and with the flame test, you need to get to understand that the color of the flame that particular given solution is going to give is because of the cation that is there. Like for instance, if you see the flame being yellow, it implies that sorry, in this particular given case, you now need to look at the flame and tell us how that particular given how that particular given solution has burnt. Like I have dipped the nichrome wire in that particular given solution, and I have burnt it over an luminous flame. So how is the learner expected to make the observation? The learner is expected to talk about the solid that particular given solution burns with a yellow flame, or that particular given solution burns with a lilac flame. So if it burns with a yellow flame, then it means that the ion which is present is sodium. If it burns with a purple flame, it means that potassium ions are present. You can have it burning at a brilliant white flame, meaning magnesium ions are present. If it burns with an orange flame, that is for the calcium ions. If it burns with a crimson or deep red flame, that is for lithium. If it burns with a green flame, that is for copper ions. And if it burns with a pale green flame, that is for barium ions. Now also I downloaded some images from the internet showing some of the colors of the flames. It's coming up next. You can have a look at it and try to, next time when you'll be in the laboratory carrying out the practical, you'll be able to try and identify the colors correctly. So we have these ones. these ones here. Those are the kind of flames you are expecting as you are putting that particular given nichrome wire that you have dipped in the test solution. So those are some of the colors that you are expecting. Now let us now also look at the universal indicator. Use of the universal indicator, or you can use the universal indicator paper. Now in this one, you just simply dip the universal indicator paper in that particular given solution, and then match that particular given paper with the pH chart that you have been provided with. Now with this one is just very simple. After matching the contents, you read on that particular given color what number has been written there. It can either be pH1, pH2, pH3 up to, you just simply read the number that you are going to see on the pH chart. So if it's something close to between 1 and 3, your inference should now be strongly acidic. And if it is for pH4, pH5 and pH6, they are weakly acidic. pH7 means that the solution is neutral. pH8, pH9 and pH10 implies that that solution is weakly basic. For pH11, pH12, pH13 and pH14 implies that that particular given solution is strongly basic. Let us look at the use of the oxidizing agent hydrogen peroxide. So you can add hydrogen peroxide to that solution, and you may see the solution changing maybe from green to yellow. That one will just be implying that the iron 2 ions are being oxidized to iron 3 ions. So I have also made here a note to remind you that some copper ions are green. Like for instance, you have copper 2 chloride and copper 2 carbonate. So their solutions, when you add the HCl to it, or if you have decomposed that particular given substance and then you add HCl to it, the resulting solution is going to be green in color, and you can now be able to differentiate and get to know if it is copper ions or iron 2 ions that are present by addition of aqueous ammonia dropwise until in excess. So in this particular given case, the only reagent that is going to make us understand whether we are having copper ions or iron 2 ions is the ammonia solution. Let us look at the test for the anions. That the first case, we have addition of lead nitrate. So when you add lead nitrate, you should have an expectation. What am I expecting? I'm expecting to form a white precipitate. Now, when you form a white precipitate, it will mean that the sulfate, sulfite, carbonate, and the chloride ions are present. So it is implying that these ions are present. That is where the acronym SOSOCOCLE comes in. Next, if you see a yellow precipitate, it will now imply that the iodide ions are present. Next, there is the use of barium nitrate. Barium nitrate, when you use it, when you see a white precipitate, you are having the sulfite, and the carbonate ions being present. Now in this particular given case, what I'm simply trying to do, I'm trying to look at, I used lead nitrate, and I found all these four ions being present. These four were present. So I want to try and eliminate by use of barium nitrate. Now, when I use barium nitrate, when I add to it, I just want to try and see of these four, which one is likely to be present. And if I see a white precipitate, it will imply that we are having either a sulfite, a sulfate, or a carbonate ion that is. Then we also have the use of barium nitrate or the use of lead nitrate followed by an acid. Or sometimes the examiner can tell you that we are adding acidified barium nitrate or we are adding acidified lead nitrate. Those two just basically mean the same thing. Now here, which observation are you expecting? You may expect to form a white precipitate that dissolves on addition of the acid. So now we should remember that I'm trying to eliminate. In the previous case, I talked about the sulfate and the sulfide and the carbonate. So I have now eliminated the sulfate and I'm now remaining with sulfite and carbonate. So if I get white precipitate insoluble on addition of the acid, if the white precipitate is insoluble, it implies that the sulfate ions are present. Next, we are having the use of acidified potassium dichromate. If you look at this case up here where I was having the sulfite and the carbonate, I can only be able to tell the specific ion which is present by use of this acidified potassium dichromate. It can help me to identify the ion that is present between the sulfite and the carbonate. Now, if the acidified potassium dichromate is going to change from orange to green, it will imply that the sulfite ion is present. But then, if the acidified potassium dichromate is going to retain its orange color, it will mean that the sulfite ion is absent. And now, let us also take keen note of this. When you are talking about the color changes, you should always be telling the initial color and the final color. Like for instance, in this last example here, the learner is strictly, if you're talking about retaining a color, the learner is strictly supposed to tell us which color is this that is being retained. So you must tell us that what color are you retaining. Next, we can also have use of potassium manganate 7. So both the potassium manganate 7 and the potassium dichromate can help us to identify if the sulfite ions are there. If I add acidified potassium manganate 7 and then it changes from purple to colorless, it will imply that the sulfite ions are present. But if it retains its purple color, it will mean that the sulfite ions are absent. And when you are also talking about the colors changing, you should get used to using the word changes. There is another word that the learners are used to, the word turns, which is not really recommended. because if you look at the dictionary and you talk about turning, we may imply something different. Though the concept is understood, but the best word for you to use is the word changes. Next, you have addition of silver nitrate. When you add silver nitrate, you may have a white precipitate, and if you have white precipitate, the only insoluble salt of silver that you know of is silver chloride, which implies that. Next, you have addition of lead nitrate and warming. You may see a white precipitate soluble on warming, which implies that the chloride and the bromide ions are present. But now, if you see if the white precipitate is not dissolving when you warm, it implies that the chloride ion and the bromide ions are absent. Next, we have the use of phenolphthalein indicator. If you are adding phenolphthalein indicator to the test solution and then the indicator changes to pink from colorless, it will mean that you are either having the OH ions, you are having the carbonate ions, or you are having the hydrogen carbonate ions. Now, the only substance that can help us the only reagent that can help us to identify of these three which ion is present is now using an acid. When you add, like for instance, hydrochloric acid to it, and then you don't see bubbles, where you'll say there is no effervescence, or you say there is no bubbles, it implies that the hydroxyl ions are present. But now, if you see bubbles, it will mean that the carbonate ions or the hydrogen carbonate ions are present. Next, let us look at the tests for nitrates. The first test for nitrates is the brown ring test, where you usually take freshly prepared iron 2 sulfate, you add it to the substance suspected to be a nitrate, and then you add concentrated sulfuric acid. Now, in this particular given context, when you are adding sulfuric acid, you usually add it when the boiling tube is in a slanting manner. Now, what observation are we expecting here? We expect it to form, as you add the concentrated sulfuric acid, it may form a brown ring at the interface, which will imply that the nitrate ions are present. We are also having the Davada's alloy test, where you take sodium hydroxide, you add aluminium foil, the solution that you are suspecting to be a nitrate, and then you warm that particular given solution and test for the gases being produced using moist red and moist blue litmus papers. Remember, I said the importance of using moist litmus papers is for you to be able to provide a medium for the dissolution of the gas that has been produced. When the litmus papers are dry, you may fail to make your observations. So in this particular given case, if you see a colorless gas that changes moist red litmus paper to blue, and that moist blue litmus paper remains blue, it will imply that the nitrate ions are present. And lastly, you can also have the substance you are suspecting to be a nitrate. You add concentrated sulfuric acid to it and warm in the presence of copper tannings. If you see brown fumes being produced, it implies that the nitrate ions are present. So now, in this particular given case, that brings us to the end of the qualitative analysis of both the qualitative analysis of inorganic chemistry. We have looked at the test for the anions, and we have also looked at the test for the cations. So now, allow me to look at the organic chemistry or the qualitative analysis of organic compounds. So we are moving on to organic chemistry. So qualitative analysis. We are also looking at it in form of a question. So you may be given the substance. It may be a solid or it may be a liquid, and you are told to take half of that particular given solid and you burn it over a flame, over an luminous flame. In this particular given context, as you are burning, when it comes to organic chemistry, you must be able to tell the color of that particular given flame that is going to be produced, and you must tell us that if there is soot being produced or not. So like for instance, if you have that solid and you burn it, then it melts and burns with a yellow sooty flame. Or you ignite that particular given liquid. You can be given a liquid on watch glass and you ignite it. If it burns with a yellow sooty flame, if it burns with a yellow flame, sometimes this aspect of talking about the flame is sooty, you need to remember that in organic chemistry, we said that different organic chemistry have different levels of unsaturation. So the organic compounds which are highly unsaturated, they are going to produce a lot of soot that the learner is able to see clearly. But in some cases, you may find that the flame is yellow, but you cannot clearly see the soot. You need to be able to understand that that particular given substance is unsaturated, but the level of its unsaturation is a little bit low. So as soon as the learner sees the flame being yellow, I always advise that you need to add there another point by telling us that I have seen a yellow sooty flame. That particular given aspect is very important. Then for the part of the inference, if it is burning with a yellow sooty flame, you are now expected to talk about the double bond or the triple bond or the long chain organic compound is present. But in case you hit that particular given solid and you find out that it is melting and burning with the blue flame, in this context, the learner is supposed to make the observation by telling the examiner that I have seen that the solid, it melted and burnt with a blue non-sooty flame. This second aspect of telling whether the substance produced a sooty or non-sooty flame is very, very important. So the learner must capture that point. If you see the flame being blue, add there the next aspect that the flame was blue and non-sooty. Or if I ignited the liquid and it burnt with the blue flame, I'll say that the liquid ignites and burns with a blue non-sooty flame. Like for instance, if you ignite ethanol, that is what you are going to expect. It will burn with a blue flame, which is non-sooty. But if you ignite another liquid like hexanol, you are going to find it burning with a yellow flame, and it usually produces a lot of soot that the learner can be able to easily see. So in this particular given context, the inference you are going to talk about the double bond, the triple bond, or long chain organic compound is absent. So you say alkene, alkyne, long chain organic compound, absent. The word absent is hidden behind behind this point where you are having my image. So you need to complete the statement by telling us that it's absent. Next, the remaining solid, you can be told to add water to it and shake. So as you are adding water in this particular given case for organic chemistry, we just want to see will the solid dissolve or will it not dissolve. So you can have the solid dissolving in water to form a solution, or if it was a liquid, you need to talk about the liquid dissolves in water to form a homogeneous solution, or you can say the liquid dissolves in water to form one layer. Now in that context, the inference you talk about polar substance is present. Next, you can have solid G. It may fail to dissolve in water, or the liquid, when you add water to it, you see it forming two layers, two distinct layers. Like for instance, if you add water to kerosene, you can see it forming two layers. It will imply that a nonpolar substance is present. Alternatively, apart from using water, we can also use ethanol as our solvent. And if that solid dissolves in ethanol, or if that liquid dissolves in ethanol, it means that a nonpolar substance is present. And if it does not dissolve in ethanol, it means that a polar substance is present. Then the resulting solution, usually after dissolving in water, the resulting solution, you are usually asked to divide it into several portions so that you can have a number of reagents that you can use to test for the portions that you have divided. So the first portion, you can be asked to add acidified potassium manganate 7. If it changes from purple to colorless, you now need to talk about double bond, triple bond, or ROH being present. Potassium manganate 7 can be used to test for these three. But if you find that the acidified potassium manganate 7 is retaining its color, its purple color. Remember, I talked about when you are talking about color changes, you must tell me if it is retaining the color, which color is this that is being retained. If it retains its purple color, it will imply that double bond, triple bond, or the ROH is absent. Next, we have the use of bromine water. Bromine water can only test for double bond or triple bond. If bromine water changes from yellow to color, bromine water is yellow in color. If it changes from yellow to colorless, it implies that alkene and alkyne are present, or rather double bond or triple bond are present. And if you have yellow bromine water retaining its color, it will mean that the double bond and the triple bond are absent. And you should remember when you are writing these functional groups, remember that this bond is not supposed to touch the C. So as you draw them, allow them to get suspended well. The next reagent that you can use is the potassium dichromate. Potassium dichromate, if I add it to the solution that I'm testing and then it changes from, so I add it and then I warm. If it changes from orange to green, it will mean ROH is present. But if it retains its orange color, it will mean that ROH is absent. The next test, we can use a red and a blue litmus paper. if you have the red litmus paper remaining red while the blue litmus paper changing to red, it will imply that the solution is acidic. Remember, the red litmus paper and the litmus papers can only tell us that the solution is either acidic or the solution is basic. So if the red litmus paper changes to red, if the red litmus paper remains red and blue litmus paper changes to red, it implies that the solution is acidic. Next, we have the use of sodium carbonate or sodium hydrogen carbonate. If you add in and then you see effervescence of a colorless gas, it will imply that the RCOOH is present. And you should always be taking note as you are making your inferences. You are required to write the inferences the way I have written them. Don't write some other funny things. You write them the way they are. That is the correct way on how you are supposed to write them. And if you add the sodium carbonate or if you add the sodium hydrogen carbonate and you fail to see effervescence, there are no bubbles produced, it will mean that the RCOOH is absent. Next, we have the use of the universal indicator, just like in the other case where we were having inorganic chemistry. For pH1, pH2, and pH3 implies that the solution is strongly acidic. And you should remember, you can only see, you don't write all the observations. You can either see pH1 or you see pH2 or you see pH3 or you see pH4. You cannot see all of them at the same time. So for pH4, pH5, and pH6, it implies that the solution is weakly acidic. pH7 means the solution is neutral. pH8, pH9, and pH10 implies that the solution is weakly basic. pH11, pH12, pH13, pH14 implies that the solution is strongly basic. Next, you may be asked to use, maybe supplied with magnesium powder, and you are asked to add it to the resulting solution and test the gas produced using a burning splint. If you see effervescence of a colorless gas that puts off a burning splint with a pop sound, now it will imply that RCOOH is present. So this is basically implying that when the solution is acidic, it is going to react with the magnesium powder to form the hydrogen gas. So it is the hydrogen gas that is burning here, and usually when hydrogen gas burns in air, it usually burns with a pop sound. And if you fail to see effervescence, it will mean that the RCOOH is absent. Next, the next portion, you may be asked to add ethanol and sulfuric acid to that solution, then warm. And you are told to waft the gases produced towards your nose. So in this particular given case, what are we expecting? We are expecting to feel a pleasant smelling substance being formed. So in this case, the observation you talk about a pleasant smelling substance has been formed. which will imply that we are having the RCOOH being present, because remember in this particular given case we are having the esterification process. We are now forming an ester when you react an ethanol with when you react an alcohol with an alkanoic acid in the presence of sulfuric acid and warm. So that has brought us to the end of the qualitative analysis now for organic chemistry. The remaining bit is just sample papers, sample questions with either the observation or the inference. So I just want you to try and look at the observations that I have provided you and try to see, if I make this observation, which inference am I expecting? Or in some questions you are going to find I have supplied you with the inference. If you see that inference, you'll try to see which observation are you supposed to write. So these questions are just sample questions that are going to help you to understand how are you supposed to make your observations, or how are you expected to make your inferences when it comes to the examination. And after every slide of the question, the next slide is having the answers. Like for instance, this slide here is having questions, and this next one is having the answers to that particular given previous slide. So you have a series of questions from this slide 43 up to slide number 76. So you can get through them. You can always pause the video, try to read the question, try to make the inference, and then play the video and try to check the answers that you made. Were they correct answers or were they not correct answers? And with this, you will have learned how to answer the chemistry paper 3 questions with ease. So allow me to end my presentation there. The slides are going to continue. It will be your responsibility to pause and find out if you have understood the concept or not. Have a nice time, and I want to believe that I have made you learn chemistry, and I have made you to understand that the practical analysis bit of chemistry is easier and it can be done.